let V be the vector space with the polynomials with the degree less than 3, okay? Consider this example. V be the vector space of polynomials with degree less than or equal to 3, okay? And let W be, again, the vector space of polynomials with degree less than 2. So I will wait for you to write that down. And now I would like to define two basis sets for these vector spaces. What is the number of elements in the first basis sets?
It should be 3.
It should be 4, right? So it will,
Sorry.
there will be 4. It's the 4 dimensions space because we have s to the power 0 as well, or t to the power 0 as well, right? So the B is given as follows: 1 plus t, 1 plus t plus t square, and 1 plus t square plus t cube. Okay. And the C basis set is given as 1 plus t and 1 plus t square. Okay. And I am given a matrix representation of a linear transformation. Okay, so A is a matrix representation of a linear transformation, let's say A. And when I say the matrix representation, what is the first question to ask? With respect to which basis sets, right? So this is with respect to B in the domain and C in the codomain. Okay, maybe I can write explicitly. So B in respect to B in the domain and C in the codomain. So I can write that A is like from B to C. Okay. All right, this A matrix is given as follows. Well, it's not going to be enough space. So A is equal to, let's see what it is, 0, 0, 0, 1, 0, 0. I should tilt my arm a little bit. Minus 1, 2, 0. Minus 1, 2, 0. And minus 1, and 3. So, 3. All right, so the first question is, so change the basis in the domain as B bar, okay? And it is given as 1, sorry, this is not 1. Oosh. Can I redo that thing? What was the shortcut for redo? Arkadaşlar undo'nun tersi için shortcut ne oluyordu?
CTRL-Y hocam.
CTRL-Y. Hadi bakalım. Oley. Basit şeyleri sevilen bir hocanız var arkadaşlar. Geri getirebildiğimde çok mutlu oldum. Şunu 1 yazacaktı. Bütün problem buydu. So B bar is given as 1 t square and t cube. All right. Okay, and so of course we will not stop here and find the matrix representation, let's say A1, which is with respect to B bar and C. Okay. So how are we going to proceed with that? So if we go back a little, top there, All right. So this is our general picture, right? So I have this B basis and C matrix and this A representation, okay? And if I would like to find this A bar in the sense that I only change B bar there, but C bar and C the same, so Q is almost identity, I can only say if I need to only find this P matrix, and P matrix does this. It takes the representation of the vectors with respect to B bar and transforms them to representation of the same vector with respect to basis B by this matrix multiplication. Okay, so all I do need the first step, I should find this guy. Where is it? So I will have n vector v with respect to b. I should be able to write as p times same vector with respect to b bar. And how do you find that p matrix? Do you remember? Of course you remember because you had a quiz last week, right? How do we do that?
Right.
So we write this,
Of...
so write these basis vectors in terms of B, yani basis vectors B diyeyim, B diyeyim, tamam mı? Kısaca. So let's do that. What is the ben direkt yazıyorum bunu, artık alışmış olmalısınız diye söylüyorum. Şu matrix direkt beraber yazalım, olur mu? So let's try to write down the B bar in terms of these guys over here, right? So what is 1 equal to in terms of these guys? I mean, the linear combination of these guys. What are the coefficients that corresponds to 1?
1, 0, 0, 0.
Exactly, and I write it here as the first column. How about t? T is equal to minus 1, 1, 0, 0, 0. So this is minus 1, 1, 0, 0. How about, maybe I can to show you some color. How about t square? So t square is equal to this minus 1, 0, plus 1, 0, right? So if you subtract this guy, you get t square only. So I will simply delete those and write down the column immediately. So it is 0, minus 1, 1, 0. How about the last column? You tell me. I would like to express t cubed instead of in terms of these base vectors. What are the coefficients?
0, 0, minus 1, 1.
Exactly. So that's my P matrix. How about this A1 matrix, which was shown as A bar in the previous derivation? So what is A1? It is equal to A times P. Okay. So I will get this A matrix and multiply by this guy, and apparently the result is this. This 0, 0, 0, 1, 0, 0, minus 2, 2, 0, and 0, minus 3, and 3. So we were able to make our first basis change without any problem. Okay. So let me continue here with one more modification. Let's also change the basis in our codomain. Okay, so say part 2 over here. So change the basis in the codomain as C bar, okay, which is equal to, if I tell you the canonical base, let me write it first, 1 t and t square, which is also the canonical basis, okay? The canonical basis is the one with the 1 t and t square. And find, let's say, A2, which is from B bar to C bar. Okay. So notice that the A matrix was given for B to C. Okay. So let me say. So this A matrix was given for B to C. We found A1 for B bar to C bar by changing the base in the domain. Now we want to change the base in the codomain as well. Okay. So what I should do is that I should get this A1 matrix and multiply by a Q matrix, right? So I decided so that this QAP A bar is going to be equal to QAP. And what is that Q matrix? So let's go up there. Okay, so this was what we are relying on. So this Q matrix takes the representation of any vector in the codomain with respect to basis C and transforms that into its representation with respect to C bar by multiplication. Okay, so I'm looking at Q matrix over here. So let's do that. So I will go down. Okay, and I would like to write that Q matrix. Okay, such that representation of W with respect to C bar is equal to Q times representation of W with respect to C. Okay. And how do I do that? I write down the vectors in C, okay, in terms of the vectors in C bar. So let's do that. So then you can tell me what the Q matrix is. Okay, so Q matrix is then. So I should be able to write the vectors in C in terms of C bar. So what are the vectors in C? So let's go up and check. So now they do C. Okay, so the C is 1 plus t, 1 plus t plus t squared. So it is easy. So how can you express the first term 1 in terms of these guys? It is 1, 0, 0. And the other one is 1 plus t. In terms of those guys is 1, 1, 0. And 1 plus t squared is equal to 1, 1, 1. Okay. And as I said before, so A2 is simply equal to Q times A1. Okay. And that is equal to, if you get this Q matrix, I multiply by A1 over here. Maybe I should also write this. This is also equal to Q times A times B. And that is equal to 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3. So we found the matrix such that so any vector, if let's say V W is AV and representation of W with respect to C bar is equal to A2 times representation of V with respect to B bar. And also we found A1 over here. So representation of W with respect to C is equal to A1 times representation of V with respect to B bar. So far so good. I think it's trivial, right? Any questions? Okay, good. So let's solve